Hi everyone. So today we'll be understanding what is eBPF tracing. So eBPF is a term that has that has started a lot since the new technologies have emerged, especially the eBPF.io, the Celium summits and such not. So before we dive in, let me tell you who am I. So I am a DevRel at a Kepler. Being a DevRel means like I explore new technologies and figure out the way how I can collaborate, use those to enhance and reach more audience to understand their pain problems. Previously, I have worked with Savo Labs and Typeoff as an API engineer, and I'm right now just another community guy who's working around and understanding what the audience actually wants. So I'll be making some small jokes in between, maybe. I don't know. You can connect with me on LinkedIn and Twitter. So my handles are Sonichigo and Sonichigo1219. And if you are interested in to know why I chose Sonichigo, you could connect with me. So when I talk about like what is eBPF, this is how eBPF looks like. It's a very complex structure, but in short, if I try to explain it, we use JavaScript and go for building our apps, right? Similarly, we use eBPF programs to build the kernel level apps or underlying the kernel apps to basically for the three use cases. That is networking, security, and observability. Nowadays, so you must have seen that we are using different kinds of tool for Prometheus, for example. We use Prometheus, Thanos, Grafana. If I break into down, at certain level now, right now Prometheus has launched an eBPF instrumentation for to enhance its capabilities as an observability part. It's there on a slide deck on their main repository, you can explore it. So for example, like eBPF can be used with different kinds of projects such as Selenium. Solo.io uses one called Bumblebee. Then we have Aya, Rust, and in DevTools, they are being incorporated to enhance the current capabilities. Why? Because eBPF are the hooks or the events that works on a kernel level. Right, when I say kernel level, so whatever tech stack you are using, for example, one could be using a very complex app with systems such as Postgres, Oracle, made using Java and some part in Flask, some part in Cosmos DB and such stuff. So those all things are irrelevant to when we are using eBPF programs because it's a language agnostic. When I say language agnostic, it basically means like no, it is a language independent. You don't have to figure out or customize it in a certain form for it to be usable. It's like an open platform. If you're using one on one VM for a dev environment where you are using production codes, right? You can directly use and hooks it attached. So if I will go a bit into, I'll come back to this. So this kind of architectures. So this is how a general architecture of eBPF programs or things that are using eBPF actually looks like. For example, if we have a client, API client, right? It will make some system calls. System calls could be read, write, open, exit, close, such stuff. And those requests are sent to the user apps. Now, once user apps have their request, okay, this is the something, then it passes it to external services. Now, in this case, external services could be my database that I'm hosting locally or in a production level on Atlas or some Azure or AWS part. Now, what Keploy does, or what Keploy is? Keploy is basically a CLI tool. It's an open source API testing tool that automatically generates realistic data mocks and test cases on just by capturing some calls, API interactions that we are happening. So everyone uses Instagram. I hope some of you have been posting stories also, Twitter, LinkedIn. So each time you post something, you start something, you log in something, those at the back end, those API calls are happening, right? So on basis of that, your test cases and API, the data mocks are generated. Now coming to the how actually eBPF works. So in the system call itself, it would have passed, okay, this is an open event. Open event means I'm sending something and the user should be or the system should be available to accept it. So that's when the eBPF hooks are attached to an event, and once that event has been captured, it moves to the system calls. Again, it has closed the exit call, or that's a closing event. When I have received the closing event, the Keploy passes the whatever data it has gotten to the proxy. And we are acting as a proxy basically because when we add a middleware, you have to add SDKs and such sort of stuff. In proxy, none of this you have to handle. You just have to start the application, and once the application has started, your network interactions are happening. It could be database to database. It could be from your production to some production app that is hosted on Azure and such stuff, or production or that stuff, or local host to create and use the same test sets on your production level. So the best thing is all the things that are being captured are stored in the YML format. When you're using YML format, there is a plus point. Those are readable and editable both. So you can use it in any Jenkins CI/CD such as Jenkins, GitHub Actions, GitLabs, buckets, and such stuff. And on the basis of your requirements, you can actually create the passing test cases and the false test cases. So that the time that is spent to generally write a single unit test or a single E2E test are being solved by this problem by using the eBPF. So this is how actually the eBPF tracing looks like. All the interactions that are happening are being captured on a kernel level by the eBPF program through the hooks. And now the hooks act as a triggers and the events for the different stuff. For each event, we have triggers, and on the basis of that, the interactions happen and those are captured. So I'm already over my time, so I'm going to just skip. Actually, it's the last slide. So thank you for your attention. I hope you got to learn something new about tracing.